Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for Know-How is brought to you by CacheFly at CacheFly.com.
This episode of Know-How is brought to you by Lynda.com. Learn what you want, when you want, with access to over 2,000 high-quality online courses and training videos, all for one low monthly price. To try it for free for 7 days, visit lynda.com/knowhow. That's LYNDA.com/knowhow. Today, you'll know how to assemble a programmable electronic kit, how to calibrate your home theater audio, and a whole lot more. Welcome to Know-How. I'm Ayaz Akhtar.
I'm Father Robert Ballecer.
And this is Twit's project show, and we've been cramming a lot more projects in now that Padre is here, joining our Know-How family. And before we started, I was running around, so I might seem a little out of breath.
You did a lot. Yeah. It's how we get our exercise.
It's a big studio. Oh, yeah. So first up, though, we're going to be... Padre, you got a project here.
Yeah. So when we...
What is this mess?
When we reformatted the show, we thought we should do more electronic kits that could teach people how to actually build their own electronic kits. So we talked to some friends over at Wayne & Lane. It's a group, an outfit that I met at the Maker Show in San Mateo.
To Sarah Lane?
You know, I didn't ask.
Lois Lane?
I think Lois Lane, because they are definitely Superman-ish. But they put together these little cool beginner kits for people who want to learn about the components that go into making something cool, something blinky, something electronic. And so we've got a matrix grid. This thing here is from Wayne & Lane, and they sent us a few of these so we could teach you how to assemble one of these with ease. Now, it's not all we're going to do. We're not just going to put this together. We actually want to explain the concepts that go behind something in the world that looks like this. Ayaz, you know what this is?
It appears to be something on a birthday cake or an LED. One of the two. I can't tell.
I don't want to eat this, so I'm going to say it's an LED. It's an LED, a light-emitting diode, and these are pretty much everywhere, right?
Yeah, I mean, if you've seen like awesome belt buckles, they actually have little flashing names and things. Usually, they're just a matrix of LEDs. So what you would have is like a sequence of them going on and off, and that's how you see all kinds of things. Think about Light Bright. That's what this thing is like.
Exactly. It looks like a light bright. And they're all the craze now because they're low power. They put out very little heat. So there's a lot of applications that could use these. They used to be really expensive, but they came down in price. And now you find them in everything. They're in car headlights. They're in flashlights. They're in computers. They backlight. And the principle behind an LED is actually really, really fascinating. We're going to talk about that in a bit. But first, I do want to talk about electronic kits because I don't know if you grew up with electronic kits, but I used to go to Radio Shack or Heath.
Yeah, Radio Shack's what we used to have.
Exactly.
You'd actually build a radio.
Right.
Before iPods and before like having all your music coming through streaming services, we had them coming through the air. You still have that. You'd build a radio. It's a really old-timey thing.
Yeah, it's old-timey, but I mean, it really did teach you about how to do things. And I don't know if you were like this, but when I was a kid, it wasn't just building the kit. It was making it work and then saying, I wonder what happens if I put this wire here. I wonder what happens if I move this over there.
Oh, yeah, you actually had intent to break. I was,
yes.
Or like that was your purpose afterwards. I'd be breaking, then trying to fix.
Okay.
Constantly.
Well,
so yeah, same kind of thing.
Exactly. Okay. We both tinker. So what we're going to do is we're going to show you some of the simple tips on how to put together one of these kits. I'm going to give this one to you.
Yay.
You get the red one.
Red is my favorite color. It just doesn't look very good on me. So I'm very happy that my project kit is.
I do blue. I do blue here. And you know,
red and blue.
There are a few things you want to look for when you're buying a project kit. The first thing is you want clear and detailed instructions. And actually, Greg's going to go over to the Wayne & Lane webpage for the instructions for this kit.
You mean Brian?
Oh, sorry, Brian. Greg's running around somewhere else. And you want something that looks like this, where it actually gives you pictures. It actually shows you what it's supposed to look like.
Look at that. It even says greeting Know-How visitors.
Exactly. See, I mean, they love us. They love us. And you want that because you don't want to get halfway through a project, not have it work, and then have no idea how to fix it. Wayne & Lane is nice because they really are part of that maker movement. They want you to figure it out. They want you to have the resources of other people who have actually made these kits. The second thing you want to look for is this. This is a printed circuit board. Now, one of the nice things about this is it actually tells you on the board where everything is supposed to go. So it labels, like, this is where the IC goes. That's where the capacitor goes. These are where the resistors go. This is all the LEDs, and it has the positive and the negative, so you know which way it goes. When you have a printed PCB like this, it makes the kit infinitely easier for you to assemble. Now, I'm going to ask something for you. You did a special on soldering. What would you say is the #1 thing that newbies make? What's the mistake that they make and it just drives you crazy?
What they love to do is they like to heat the solder directly, because what they think is, if I heat the solder, it'll melt, it'll combine, it'll connect these two components, and you'll have something. What they end up with is this big, ugly gray glob that may work, but it would call, what do they call it? It's a cold solder?
Yeah, cold solder.
Joint, excuse me. Yeah. Cold joint, when you have that, so it may be, what's the word, not reliable, it's unreliable. So what you want to do, though, is heat the pad and let the solder melt onto it.
Right, exactly. I used to do that. I used to take a little glob of solder and then I'd put it on and I'd say, oh, look, it sticks, so it must be good. But as you said, there could be an air gap, there could be a bubble. It might stick, but there's no actual...
You could use it as an adhesive,
exactly.
But that's not what you want. You want an actual electrical connection between the two components.
Yeah. So that's #1. I'd say #2 is this. So people who make electronic kits, they often put in the component, they go, oh, great, and then they turn it over so that they could solder, and it does that.
The infomercial style, falling out right there.
Yeah, it falls right out. So there is something that kit people do, and it's called a tack. And so what you can see here is I've got my little piece of solder up on the wire. I've got my soldering iron that's already heated up. I'm going to heat up the pad first, like so.
This requires patience, people.
It requires patience. And then I'm going to go ahead and touch the solder to it. And what I've done now is there's actually a piece of it's not super neat, but the nice thing is it'll actually hold it in there. See, that little socket is now going to stay in. Now, if this is uneven, so if the socket's not flush, I can just reheat it and reseat it. And you can do this for all the LEDs. So when you're putting in LEDs, you can just make sure that you put it into the right orientation. So I've got my anode and my cathode, like so. And then I'll go ahead and apply a little bit of solder to one side.
And usually you want to do this in a well-ventilated area, folks. You don't want to breathe in this stuff in general.
It's not good for you. And now I've got one side of the LED that's tacked in. Now you'll notice this is not flush. That LED it didn't go in right.
Right, it's a little up there on the board.
It's a little up there. I want it flush mounted. But now the LED is not going to go anywhere. So what I can do is I can just reheat. Give it a little bit of pressure.
Now you're heating the pad, right?
I'm heating the pad, right?
Okay.
Just the pad. And now, if you look at it, this thing is totally flush. See? And I can do that for the entire row of LEDs. I do just one tack, one tack, one tack, one tack. And once I'm convinced that they all line up properly, they're all flush, I can go ahead and put solder into the other joint.
Yeah, so theoretically, so instead of it like kind of falling out, and you're just trying to get everything situated first, then you can adjust to make the things completely flush with your board, making a very neat finished product.
Neat, right? Because what you don't want is you don't want these LEDs in the end to have, you know, one's pointing this way, one's pointing that way.
It'll work.
It'll work, but it'll look ugly. And at the end, you're going to go, oh, my kit's kind of
That's how you learn.
That's how you learn. But what I'm going to do is I'm going to give this to you. I'm going to let you start soldering in some of these things. And I want to discuss a little bit about what an LED is and how it actually works. So an LED is a light-emitting diode. And as the name might imply, it's a diode. A diode is a dipole device, which means current goes in one way, it doesn't go the other. So if I take an LED like this, and I use a battery like this is just a lithium-ion cell battery, and I put it in the wrong way. So this is putting positive on the negative side and negative on the positive side. You see there's no light. There's, you know, it doesn't light up. I flip it around, and now I do have light. So current can only flow in one direction. That's why it's really important for you to put the LEDs in the right way. Now, the way this works, now we're going to get super geeky here. We should have a banner for Super Geek Alert. Is it actually uses what's called a PN junction, positive negative junction. It uses the cathode and the anode that's been doped in a certain material so that when you run a current through it, it forces electrons out from the negative side. It forces electron holes out from the positive side. They combine in this p-n junction, and Brian actually has a video that shows how this works. And as they combine, the electrons have to lose power to fit in the holes. And so as they lose power, they emit a photon, and that photon is light. Now, how much energy they lose, so how big that gap is going to determine what kind of light is emitted, either infrared or ultraviolet, all the way through the visible spectrum of light. It's a really, really cool process, and it happens each and every time you turn on an LED light. So in our LED, we've got the positive side and the negative side. We're going to run a current through them, and as we do, they start to come together, and when they hit, boom, you get a photon. That's your light. That light is actually focused by the little plastic, the lens assembly around the LED to push out light in a specific direction. And this is the basis of every LED technology that's currently on the market. It's cool. It's cool, right?
It's definitely very cool. It's, you know, sometimes you just see the stuff work. You want to make it work, but to know how it works makes it a total difference. Because once you understand how this actually works, that's when you get to either design them on your own. Right. This is for the bigger thinking of how can I design something that does this a better way. But if you know the basics of this, then you can come up with a different one. Because it was in the old days that these, like you mentioned, were expensive, harder to get, and I remember they had problems with color accuracy, all kinds of things that when you know the basics, you can eventually design something that can do a better job.
Yeah. And they're so much different than light you had before, because previously light had been based on incandescent, which means it's heat. Right, you just heat it up until it glows and you get light. Or some sort of chemical reaction or some sort of photo reaction, like a fluorescent light. This actually turns current straight into photons. That's why it's low power, and that's why it's low heat. So, you know, I think what we should do is we should actually assemble this kit.
Okay.
And we'll show you what it looks like at the end and how you could assemble your own.
Now, let's actually quickly, before we jump into a little pause here, let's talk about the equipment you got here. You've got something holding the solder for you. Some folks are asking, what's that metal block? This is just like a third hand.
This is a third hand, right. Because as you see, it's difficult to hold components and the board at the same time. So this thing will actually clamp onto the board.
What is this piece here? It looks like a magnet or something.
Yeah, that's so that I could like push it when I need to hold a component against the board. You know, I still kind of like doing it the old-fashioned way, which is putting components in and jamming it up against the table. But sometimes it really does help.
Third hands are really helpful. You're also using a Weller soldering iron. You can, like the one when we did our episode a long time ago, I think episode 7, we were using a super fun Radio Shack style one. Now, the thing about Radio Shack's soldering irons is that they will work, but you have a lot less control. It's a beginner's kind of thing. It's like that $10 guitar you buy that's just guaranteed not to break. That's pretty much what that soldering iron's about. But with Weller, these particular kinds, you can actually dial in the heat, and that lets you have much more control, and you're not necessarily waiting as long before you start soldering. You know how to do this stuff.
Yeah, you can tell it exactly what kind of output wattage you want at the tip of the iron. And that adjustability means that you don't burn things, and it also means that you don't sit there waiting forever for it to heat up to the point where you can melt the solder.
Yeah, because otherwise you're just like, is it ready? Is it ready?
Well, that's also dangerous, because if you leave the tip on there too long, the heat will actually start to transfer into the component, and then you end up melting.
Broken stuff. Well, we're going to get to that soldering in a second, but let's take a quick break and thank our sponsor, lynda.com. Now, lynda.com is an online learning company that helps anyone learn creative, software, business skills, any skills you can think of. We know you guys who are watching know how you love to learn. lynda.com is a great place for this kind of stuff. If you get a lynda.com subscription, members receive unlimited access to a vast library of high quality, current, and engaging video tutorials across a wide variety of subjects. Now, personally, I've been messing with the Premiere Pro CS6 for Avid and Final Cut editors. In my old life, I used to do a lot of Final Cut editing. And then Apple decided to change everything, and that kind of irritated me. I wanted to see if I had different options. Premiere is available cross-platform, lets me get out of the whole Mac universe if I wanted to. And these tutorials are actually, they are taught by professionals, experts. This particular tutorial is taught by a guy whose job it is to help people transition over from Final Cut to Premiere or Avid to Premiere. The idea being that you have a lot of the ideas down, but the translation is in the little details. So these courses are fantastic for that. I've been using that a lot. There's over 2,000 courses with new courses added daily. Now this week, they've added courses that include project management, Illustrator for Creative Cloud, architectural photography, and AutoCAD 2014. So if you're like planning a city, AutoCAD might help you out there. The instructors, like I mentioned, are working professionals at the top of their fields. I was actually taking a look around for Photoshop stuff. I found Bert Monroy, Tech TV's friend and Pixel Perfect's past host. He was actually showing you how to use the new version of Photoshop as well. The high quality video production is fantastic. You're not like stuck with this whole YouTube style thing where you can't hear somebody or the video is not so good or like it's compressed to death. Lynda.com has fantastically high quality video production and there's curated course content. Each Lynda course is carefully structured so that users can learn from start to finish or jump to a specific chapter for quick answers. It's really laid out very easily. Just click around on the playlists. You can have playlists and bookmarks so you can organize the courses into a customized learning path. The tutorials cover a wide range of technical skills, creative techniques, business strategies. Did you know there's even a course about how to negotiate a raise? It's actually at lynda.com. So all of that stuff, by the way, that whole catalog, no matter what you're interested in, is available with that subscription. You can watch from your computer, a tablet, or mobile device. You switch back and forth. So you start off on your PC, and then you go to your tablet. You're going to be set to that same video that you were watching on the PC. So if you're on the go, you could do some learning. You set the pace with their mobile apps. Now, if you want to try out lynda.com, it's only $25 a month for access to Lynda's entire course library. You're not getting this limited thing. You're getting their entire library. Or for $37.50 a month, you can subscribe to the premium plan, which includes exercise files that let you follow along with the instructor's project using the same assets the instructors are using. It's like having the teacher's guide, and they're actually showing you how to do that. And for you guys who are watching Know How, because you love to learn, dig this. You could try out lynda.com right now with a free 7-day trial. If you visit lynda.com/knowhow, you can access that entire library. Over 2,000 courses for free for 7 days. That's lynda.com/knowhow. And we thank lynda.com for their support of Know How. Awesome stuff there. It's just great, great material. So we're going to start messing with this.
Yep. We got to assemble this kit, and you know, there's another part. Once we get it working, we got to show them how to actually program it.
So we're going to actually work on that now. But I got a chance to talk to a supreme know-it-all when it came to revamping my home theater at home. Because right now, I painted the walls, I reset everything, and I wanted to know what I could do to have a better home theater experience. Let's go to the know-it-alls. You know, we wanted to talk about home theater calibration, and we're like, who could we possibly get? Who is the know-it-all of all know-it-alls when it comes to home theaters? Who's a home theater geek? And then, luckily, we somehow got Scott Wilkinson in with us of Home Theater Geeks. Scott, how are you doing?
I'm doing great, thanks.
All right, so I want to talk a little bit about audio calibration, or actually I want to ask you a bunch of questions about audio calibration. When people are thinking home theaters, they're thinking giant screens, but sometimes they seem to forget that audio is important.
Audio is at least half the story. You know, if you don't have audio, you're watching TV silently and you don't know what's going on.
Yep.
So you really need that. You really need the audio experience, and it really does add a level of emotional involvement that you don't get otherwise. And so it's important to think about the audio. And you're right, a lot of people don't give it enough thought.
If let's say you were in this is our room, our room for calibration. What's wrong with this room when it comes to, or what should we do to calibrate this room for audio?
A lot. It's a pretty bad room. Now, it's not too bad. The problem is that it's way open. It's not well defined, and so the sound kind of bounces all around, and it comes back from different places. This brick facade, which you probably can't see on this video, but there's a corrugated metal here, which is kind of weird. Even this chalkboard would be very reflective. The more reflective, to a certain point, the room is, the worse it's going to sound, because it's going to reinforce what are called standing waves, otherwise known as room modes. Okay. So what room modes are, in particular, they're problematic in the low frequencies. So you have a room, and in particular, you've got a subwoofer that's producing the low frequencies. So you have a subwoofer here, and it's producing these low frequencies. Depending on the dimensions of the room, this way, this way and towards the ceiling as well. I'm pretending we're looking down here. There are certain frequencies that are going to get reinforced by this room, and the wavelength of the sound is going to correspond to the length of the room this way and the length of the room this way. And those particular frequencies are going to get reinforced. And if you're sitting right here, you're going to hear them really loud. But if you're sitting over here, you're not going to hear them at all. So the problem is then the sound becomes very uneven. And you want to make it more even so that people sitting, say your screen is here and you've got some seats here, the people in the front row are going to really hear that standing wave, that room mode. But the people here are not. So we need to balance it out. And the way to balance it out, well, there's several ways. The most expensive but best way is to build your room from scratch.
Build it from scratch.
From scratch, with certain dimensions.
Is there actually a sweet spot for dimensions when it comes to this kind of thing?
There is.
Okay.
It's a little bit complicated. It's kind of mathematical, but you don't want, for example, a cubical room. You don't want this dimension, D1 and D2, you don't want those to be the same. And in particular, you don't want the ceiling height to be the same either, because then it's going to reinforce certain frequencies in 3 dimensions, and it's going to be really bad. So you want all the dimensions of the room to be significantly different, but not even multiples of each other. Like, you don't want this to be twice as long as this. The actual ratios are not even multiples.
Okay.
They're complicated. So if you can do that, great. That's the best thing to do.
Let's assume you can build your own room, which is not something a lot of people can do. They usually end up moving into an apartment, or they move into a house that, could you imagine, was pre-built. It's crazy. But
I know.
What could they possibly, let's say we're in a cubicle style room, or a room that you can't control the dimensions. What's something, a low-cost kind of method to kind of control what could be going on with all these bouncing audio waves?
Well, let me first say that the high-cost way is to hire an acoustician, who's a guy or gal who knows acoustics very well and can treat the room, can put different kinds of room treatments on the walls that will either absorb certain frequencies or diffuse certain frequencies, so that when a sound wave hits it, it starts going off in all directions rather than simply being reflected straight.
See, I always thought if you have a big room with lots of hard surfaces, you want to absorb as much as you can. But you're saying there should be potentially diffusing and what was the other one?
Some absorbing and some reflecting.
Okay.
There are 3 different kinds of acoustic treatments: absorbers, diffusers, reflectors. And where you place them is a science and a bit of an art even all to itself. So you can hire somebody to do that. If you can't afford that, then you go to the low-cost solution, which is simply put some curtains up, put some rugs down, put some bookshelves up. Bookshelves are great because books are at different levels, they're different heights, and so they act as diffusers. They actually kind of diffuse the sound that reflects off of them. You want some reflections, because otherwise it sounds very unnatural. The goal of the home theater really is to replicate the experience that the director intended you to have. Right? And the director is sitting in a sound room, listening to the sound, watching the picture. The video has been calibrated a certain way, the audio has been calibrated a certain way, and that's what you want to try and replicate at home. And so your acoustic situation is the first step. Many people refer to the room as another component in your audio system.
Really?
Yeah, so like your receiver, like your speakers, like your Blu-ray player, like your TV, your room is another component in your system. And you need to treat it or set it up, calibrate it, just as you would your receiver and your TV and so on like that.
Yeah, so these AVRs these days, they seem to be becoming a lot of them, the higher end ones come with microphones at this point.
Yes.
Now what is this is something people should be using, right? It's to help calibrate their AVRs and have the real audio sound, because there's also delays going on when it comes to the audio reaching your ears at the points, right?
Right, exactly right. And so most AV receivers today have what's called an auto calibration or auto room correction. And so they come with a microphone, as you say. You put the microphone out in the middle of the room, in the seating area. So if this is your seating area here, I know I'm getting kind of messy on my chalkboard, and you've got 3 seats here, 3 seats here, 3 seats here, you probably want to put the microphone about in the middle. And Then you basically hit a button on the AV receiver that says, okay, go. And what it does is, here's an eraser. Let me clean this up a little bit and show you exactly.
I wish I could clean my home theater space like that.
Wouldn't that be
like,
nice?
I'm going to clear
wish
out
I
the whole
could
space.
too.
I don't have one of those yet.
Okay, so you got a couple of rows of seats here.
Okay.
And you put the microphone here. You've got your front speakers here, your center speaker here, your surround speakers here. And this is, by the way, an important thing to do when you're setting up your theater or your media room, is to place the speakers properly. You want your...
So there's like a sweet spot middle.
Exactly. Your center speaker is going to be right in front of you, either directly above or directly below the screen. Your front speakers are 30 to 45 degrees that way and that way. Your side surround speakers are like on the order of 110 degrees this way and this way. And if you have back surround speakers, there is no real...
This is for 7.1?
This is for 7.1.
Okay.
What we've done so far is 5.1.
Okay.
1, 2, 3, 4, 5, 6, 7 if you want these back surround speakers. Then where do you put the subwoofer? The subwoofer is another interesting problem. Some people put it in the corner. That tends to reinforce the bass, make it louder. I prefer it to be either at the halfway point or the quarter point against a wall, which reduces, when you put it in a corner like this, you tend to get more of these standing waves, which I was telling you about before.
So that big loud noise is what you're
Big loud noise in
Okay.
certain locations.
Right.
So putting it at the halfway or quarter way point along the wall actually reduces that problem to some degree, depending again on the dimensions of the room. Okay, so once you have the speakers placed properly, you put your microphone in the middle and you go to your AV receiver and you say, okay, go. And what it does is it plays basically white noise, which is just sounds like that, out of this speaker, out of this speaker, this speaker, this speaker, out of all the speakers. The microphone measures the level of the sound and sends that information back to the receiver. And the receiver says, okay, this speaker can reproduce this range of frequencies and it's this far away. This one can reproduce this range of frequencies and it's that far away. So it measures the distance to each speaker, which also sets the delays. You mentioned delays earlier. If a speaker is farther away, you want its signal to be delayed less than if a speaker is closer, so that the time that it takes the sound to arrive from this one to your position and this one to your position is the same. That's the issue of delay. Now, so you finish that up. Basically, it's a very loud process. And so what I do is I hit go and I leave the room because it's loud.
Okay.
The reference level, this is really amazing to me. The reference level defined by various people is 85 decibels, which is loud. That's loud. I myself calibrate to 75 decibels, which is somewhat less, because I don't like listening at that loud level. So anyway, but when the receiver does it does it usually at 85.
All right, so we're going to continue that thing in a part 2. Now, some folks in the chat room were wondering, okay, they got lost at when Scott's mentioning acoustician, which I have a hard time saying. Don't worry, we'll have full show notes at twit.tv/KH. Trust me, I was there for that episode when we were recording it, or that segment. I've helped edit it. I've been paying attention to the things. I wrote some really good show notes for this, I promise. twit.tv/KH. You'll have that. There'll be a second part about tweaks you can do to auto calibration. Because just because you have an AVR that helps you with the microphone, there are things that you can learn from Scott Wilkinson. Well, go figure, because he's a genius. He's going to help us and show us what we can do to tweak our home theater setups. And then there's even more. We got some video stuff from him and some awesome secrets coming up, or little surprises coming up. And shall we go back to our soldering goodness?
I think so. I think we've made pretty good progress. So we've turned our kits into more or less finished product. Here we have This is the blue blinky.
This would be the cooking show technique of do it before.
Absolutely. See?
Yeah, I like it.
And so you've got a battery pack, you've got all the LEDs set out in a grid. We've gone ahead and soldered and then snipped the leads. We could go back over this a little later.
Sorry.
Yeah, but we sand them down, so it'll make them nice and
all
neat
right,
and
I like that.
good for children and such. But so one of the things that we have to show is this. This is actually a microcontroller. It's not just a memory chip. It allows us to program this so we can run custom messages across this grid. Now, the way it works is these two, what look like LEDs, those are not actually LEDs. These are light sensors. One is for D, data. One is for C, clock. You need those two things in order to be able to program this via your screen. What does that mean?
You're going to program this via screen?
Yeah. There's
like this old Timex watch thing?
Exactly. Yeah. The old timers may remember those watches you used to hold up to your monitors. Well, yeah, this is the exact same thing.
Get out of here.
It's
on
the
this
same
kit.
technology.
All right.
Yeah. But so on the Wayne & Lane website, Brian's going to switch over to my screen right now. They have this Blinky POV and Blinky Grid programming page.
Okay.
This is the cool thing. You don't have to download anything on your computer. It's done all through their web interface.
Now, as a warning, if you do suffer from seizures and I'm not even kidding. This is not a joke. Really. I'm usually sarcastic and things, but we're going to have a bunch of flashing things happening on the screen to program the device you have there. If you have any epileptic problems, this is probably a bad idea to look at.
Don't look at this. Don't look at this. So what I've done is I've gone ahead and I've programmed a few little pixel things, but I can also program in text. So I could switch this over to text, and then I could put like hello world and go ahead and type something in. And once I have all the little messages I want in there, I just go down to the bottom, and here, where it says go, I click, well, first of all, hold on, switch back. You see, I'm going to go ahead and I hold down the programming button. So now
that's that white button there is causing that LED to flash to let you know that it's ready to receive.
And then what I'm going to do is I'm going to hold this up to the screen, and Brian's going to switch back, and I'm going to click go. And what it's doing right now is it's actually programming via the sensors the microprocessor on the board. Each flash corresponds to on or off, binary, and the clock keeps it in sync so that it knows where those flashes are supposed to be. Now, let me say this can be kind of delicate depending on what kind of monitor you have. You don't want it in a super bright place. You don't want it so that your monitor has so much glare, because then it can't really tell the difference between light and no light, light and black. And as soon as this is done, what we're going to see, hold on, wait for that to finish.
So you got to be patient. So I guess the more you program, the longer this will take. It looks like you had a bunch of different messages that you'll have appearing on that LED.
And there we go.
Grid.
And now if Brian switches back, see what we have is that exact pattern that I programmed, including the TWiT logo, and it just flips back and forth. Now I could have this doing letters. I could make a message that scrolls marquee across. And this is all contained within the same chip. The same chip that stores the memory also has the microcontroller, also controls the light sensors. A very, very cool little kit. Now I will say that yours, I believe, is programmed to say TWiT Army. So if we turn yours on, yours actually does scroll a little message saying TWiT Army.
So we can just, what we'll do is we'll make a bunch of these and we'll hand them out at the next meetup.
Exactly.
Just smack them onto people. What do you think?
Well, yeah, this is one of those things that you could actually create and put on your lapel, as a little badge. It's a cool
big
little
lapel
project. Oh yeah, well okay.
As long as you got a double-breasted suit, might be a way to go.
I'm a big man. Yeah. But I will say that I want to thank Wayne & Lane, the group that handed these out to us, and they've actually made a page for any of the kits that they want us to assemble on Know-How. So right now, if you go to wayneandlane.com/knowhow, you'll be able to buy this exact same kit, and you can assemble it just like we did on the show, and be able to put on your custom messages. In fact, let me go one step further. Let me say this. So what I want you to do is I want you to go ahead and go over to the Wayne & Lane site. They've actually set up a landing page for our know-it-alls at wayneandlane.com/KH. There you'll be able to see all the kits that we build on the show, and hey, how about this? If you like what we built, why not pick one up, assemble it, and then take a video of your little message, the message that you program onto your Blinky Light kit, and send it to us at TWiTKH hashtag on Twitter. And who knows, if it's good enough, we may show it on the show.
I do request that you keep the profanities for NSFW show.
Yes.
Maybe if, you know, that kind of stuff, try to keep it clean. Ladies and gentlemen, we wouldn't mind that. You know, because I know sometimes when I get frustrated with my machines and the program isn't working, I will sometimes use some salty blue language because I got blue LEDs. Why not some blue language? That actually brings us to our quick tip for this week.
Yes.
When things fail on Mac. If you've ever had an application absolutely freeze on you and it's just not responding, there's a bunch of ways on OS X that you can actually kill that application. The first one's the easiest one. It's called Force Quit. You hit the Apple menu, you go into Force Quit, and you'll be greeted with this little menu. It tells you all the apps you have running. In my case, Chrome, Safari, Stickies, and such. By the way, when your application freezes, let's say it's Chrome or something, it might be on top of that window, so you don't even know it's there. Try to move things around, maybe even change your space. You'll be able to see Force Quit. That's one of the easier ways to kill things. If that doesn't work, don't underestimate Activity Monitor. The quickest way to find that is just a quick Spotlight search. You go into Spotlight, type in Activity Monitor, or if you're not in the Spotlight mode, go into Applications, then the Utilities folder in there, bring up Activity Monitor. Here you'll have a list of all the processes that are running. So you'll see a lot of things in this particular case. There's actually a filter you can search for the application that's dead. Let's say Twitter died. You select Twitter, you hit Quit Process, and then you'll see this little dialog window come up. Are you sure you want to quit Twitter? Yes, I do. We're going to hit Force Quit, and you'll see the window disappear. Now, if both of those fail, because sometimes they do, let's say your dock or Finder absolutely dies on you. So basically, you have lost a lot of functionality there. What you want to do is go into the terminal. That's also located in Applications and then a Utilities folder in there, or you can do a Spotlight search for that as well. So we'll open that up. Now, OS X is built on Unix, so if you know anything about Unix, you know there's all kinds of commands you can use. We're going to use the kill all command, so I'm going to type in kill all. If your dock's not responding, what we're going to do is type in the command kill all and then write dock after that, because that's the process. Dock, by the way, also takes care of spaces, so if for some reason your space 2, space 3, something's frozen up, you can actually use this command to reboot that too. So you're going to hit kill all dock, and you can see that my screen actually went gray, and that my dock went away and it came back. The reason for that is because when you kill the dock, one of the first things that OS X wants to do is bring it back, because you need it back. And then you'll notice everything runs really smoothly. These are terminal commands. Make sure you spell them right, because I know I keep running into this problem. Let's say I want Google Chrome to die a terrible death. I can do that. I will type slowly, K-I-L-L-A-L-L. And since Google Chrome is 2 words as an application, use a single quote. We have to use single quotes, so that way the terminal knows what process to kill. Google Chrome, and another single quote, and now Google Chrome should die. And that does it for how to kill all your process. You can see in my dock the little light went away from Google Chrome because the light indicates that it was active. Now it is dead. So that takes care of everything. If you got a frozen process, frozen application, now you know 3 different ways to kill that unresponsive application.
I love that. The whole idea of when stuff fails. Are you going to do this on a regular basis? Quick tips?
Well, that stuff, that was a particular terminal command about killing the dock when things go awful. I've had to learn a lot of terminal commands, so they'll come up from time to time. A whole bunch of stuff I want to show people how to do. So yeah, quick tips always will be on this show, I think, as long as somebody shoots them, puts them in the show, you know.
Yeah. As long as stuff fails, we'll always have something to talk about. Go figure.
Well, guys, I think we've reached an end of an episode. So if you have questions, comments, concerns, you're like, hey, okay, what happened? What exactly happened in the episode? I have no idea. Like, you guys talk so fast during the live version, or like those instructions are great just to hear, but what if I wanted to read them? Go to twit.tv/KH. We've got tons of show notes explaining the projects we're doing. We'll have links to everything we're talking about. Everything's available at twit.tv/KH. Last week, I was jumping around Padre like an idiot. Why was I doing that? You should go check it out.
You should find out. Yeah, you got to download the episode to find out.
What if people wanted to email us? What should they do?
You know, if they want to email us, what they should do is write a really, really, really long letter. Proofread it. Make sure it actually makes sense. And then go ahead and send it to us at knowhow.twit.tv. at twit.tv. That's KNOWHOW. You know how to spell that. At twit.tv. We'll read it, and you know what? If it's good enough, who knows? Maybe it's going to guide a future episode of Know How.
Yeah, as opposed to the long, rambly ones. Yeah. Well thought out ones are fantastic. Like bullet points, really great. But the thing is, if you got questions and comments or show ideas, we love getting them there. I personally love going to Google+, because at gplus.to/twitkh, that's where you can find our community. Over 4,000 people hanging out at the Google+ community for Know How. If you want, go to gplus.to/twitkh. If you got show ideas or questions or comments, I really like seeing it here on Google+, because that means the whole community can see what's going on, and you guys can actually have a discussion, because there's been all kinds of cool projects that come up there, ideas for the program, and we love seeing that kind of stuff.
We do. And you know, G+ is not the only place that we can be found in social media space. You could also, as I mentioned before, send us an idea for the show, a question about the show, or a complaint about the show. Actually, don't do that last one. I have a really fragile ego. But go ahead and tweet it to us with the hashtag TwitKH, and you know, we'll pick it up when we get time.
Yeah, we get lots of great ideas there too, and because I am one who loves brevity, Twitter is fantastic as well, because 140 characters. That's hashtag TwitKH, fantastic resource. Also, you know, you should do your own search for that thing. You'll see all the ideas people have. It's really lots of fun.
It's pretty impressive.
Well, I think that pretty much does it for us this week.
Yeah, we're going to come back with a brand new stellar show next week, but until then...
I think 30% new.
30% new. Yeah, that's about right. The rest is recycled. You know, we're
bringing up expectations, do I?
Oh,
okay,
sorry.
Got to bring them low.
My bad.
Then it'll be fantastic.
It's going to be horrible, but check in anyways.
Now you know how. Now you know how to do this kit, or at least you know where to get one. Go get one of these kits. Do this over the weekend. It'll be fun. Let us know. Now you know how. Go do it. Go.